let's look at this. The division algorithm. Basically, you have g of x is our divisor, q of x is our quotient, and r of x is our remainder. This is the kind of format that you may see some of the homework in. And yeah. So we're it. Okay, so let's take a look at an example of division. Before we get into synthetic division with polynomials, let's look at just regular plain old division with numbers in it. Such as if we had 257 divided by 2, where 257 would be the dividend, and the 2 would be the divisor. So in long division, the dividend goes under the division sign. The divisor goes outside. Your answer in division is the quotient. And whatever's left over is the remainder. Okay, so the 2 is your divisor. That would go outside. The 257, that's your dividend. That goes inside. So you ask yourself, what 2 goes into 2 how many times? Well, 2 goes into 2 once. So we could say 1 times 2 is 2. And then we have to subtract. We have to subtract the bottom row. And the 2's cancel out. Well, we don't normally put 0 here. And the next thing we do is bring down the 5. And then we ask ourselves, what times 2 gives us 5? Well, 2 does, right? 2 times 2 is 4. And then we subtract. Well, 5 minus 4 is 1. Well, 2 doesn't divide into 1, so we have to bring the 7 down. So we ask ourselves, what 2 can divide into 17 how many times? Well, 2 times 8 is 16, right? So 2 times 8 is 16. Subtract the bottom row again. 17 minus 16 is 1. So 128 is our quotient. And 1 is our remainder. Well, the same process is used in dividing polynomials as well. So let's look at an example where we're dividing polynomials. Here we have 3x cubed minus 2x squared minus 150 over x minus 4. Well, using long division, the numerator, that's our dividend. The denominator, that's our divisor. So we put x minus 4 on the outside. And we have to have a place for x cubed. We have to have a place for x squared. We have to have a place for x. And we have to have a place for our constant. So we have the 3x cubed. And then minus, and we have a place for x squared, minus 2x squared. But we don't have a place for x. So in that case, we just use 0x. So, and so then we just go from there. Minus 150 is our constant. All right, so let me bring in Tyler. Okay, so any questions so far? Welcome, Tyler. All right, so we ask ourselves, cover this up. We ask ourselves, what times x will give us 3x cubed? Well, x squared times x will give us x cubed. And if we put a 3 in front of that, we get 3x squared times x will give us 3x cubed. So we want to, but we have to go ahead and multiply in both terms, the x and the minus 4. And that's why we need a place for each value for x, because we have to distribute whatever's in a quotient into everything. So 3x squared times a minus 4, 3 times 4 is 12x squared. Okay, so questions with that so far? Now, because we have to subtract that bottom row, just like we did with numbers, right? When we subtract numbers, we always had to subtract that bottom row. Well, we have to do that here. So it's like we're distributing that negative. So we distribute the negative. So that's going to be like distributing negative 1. So that makes the 3x cubed a negative. Negative times negative makes the 12x squared a positive. Now, if the signs are the opposite, we subtract. If the signs are the same, we add. So you got positive 3x cubed and a negative 3x squared. They go to 0. Well, we don't normally write 0x cubed. We just leave it as 0. And that's what we want. The whole idea is to eliminate the first term in every row. Next, we look at a positive 12x squared and a negative 2x squared. So the signs are opposite, so we have to subtract. Well, positive is greater than the negative. There's 12 positives and only 2 negatives, so we're going to get a positive. 12 minus 2 is 10. X squared. Okay, so now we bring the next term down, plus 0x. Just like we did with numbers. We brought the 5 down and the 7 down when we were dividing numbers, and we do the same thing when we're dividing polynomials. Now we look to see if the first term is positive, we put a plus. If the first term in the next row is a negative, then we put a minus. Well, this is positive, so we put a plus there. So we ask ourselves, what times x will give us x squared? Let's start with that first. Well, x does. X times x is x squared. And so if we put 10 times x, that gives us 10x squared. So 10x times x is 10x squared. And 10x times a minus 4 is a minus 40x. Questions with that? Again, we subtract. So we have to change the signs in the bottom row. So the 10x squared becomes negative. The 40x squared becomes a positive. So the 10x, positive 10x squared, negative 10x squared cancel out. They go to 0. That's what we want. 0 plus 40, that'll bring 40x. That'll just bring 40x. Okay, so now we bring down the minus 150. So, Alex, can you go ahead and mute your mic so that, and then just unmute it if you want to ask a question. Thank you. Appreciate it. Okay, now the 40 is a positive, so we put a plus here. And we ask ourselves, what times x will give us 40x? Well, 40 does. 40 times x gives us 40x. And then 40 times 4, well, 4 times 4 is 16. So 40 times 4 is a minus 160. What do we do now? We distribute the negative in the bottom row. 40 becomes a negative, 160 becomes a positive. So you got a positive 40x and a negative 40x. They cancel out. And you got a negative 150 and a positive 160. You get a positive 10. So our quotient is our answer, right? Our quotient is 3x squared. 3x squared plus 10x plus 40, and then you put plus the remainder, which is 10 over your divisor, x minus 4. And this is your answer. Okay, you have your quotient, your remainder, and your divisor always goes underneath the remainder. Any questions with that? Okay. Now, we can do this same problem using synthetic division. And let's see how that works. What we do here, I'll rewrite this. We started with 3x cubed minus 2x squared minus 150 over x minus 4. Okay, in synthetic division, what you do is you take the additive inverse. Additive inverse to your divisor. So this is minus 4, so you put a plus 4. Well, why do you do that? Because now you don't have to apply the minus sign every time, because when you put the additive inverse right away, it's like you're already subtracting. And then we're going to flip the division sign, and now we're just going to put the first the coefficients for x cubed, coefficient for x squared, coefficient for x, and coefficient for our constant. Well, 3 is our coefficient for x cubed. A minus 2 is our coefficient for x squared. We don't have an x, so we got to put a 0. And minus 150. for our constant. Draw a line. First thing we do is drop the first number down to you've got your first row, your second row, and your third row. You drop the first number down to the third row. And now you're going to multiply your divisor times whatever you have in the third row. And you're going to, whatever you get there, you put that on the second row. So 4 times 3 is 12. That's what goes in the second row. Now, whatever the signs are, if the signs are opposite, you subtract. If the signs are the same, you add. So you got a -2 and a +12, you subtract and you get 10. So now we're going to multiply 4 times the bottom number again. 4 times 10 is 40. Put it in the second row. And again, add or subtract based on the signs. You got a 0 and 40, so that'll be 40. And now we multiply the divisor times the bottom number again. 4 times 40 is 160. If the signs are opposite, you subtract. If the signs are the same, you add. You got -150 and a +160. We subtract, and we get a +10 because there's more positive than negative. So this is our quotient. The last number is always the remainder. So what you do here in the quotient is you take one of the x's away. So instead of 3x cubed, now you have 3x squared. And then each number after that is 1x lower, plus 10x plus 40 plus 10 over your divisor was x minus 4. And you look, the answers for dividing the polynomials using long division and dividing using synthetic division is the same. The only difference is the process for synthetic division is a whole lot easier and a whole lot faster. All right, any questions with that? Okay, so let's look at the slide real quick before we go on to the next problem. Here we go. Just making sure we don't have anybody else trying to come in. Okay. All right. So we went through all that. Okay, caution, to avoid errors, use 0 as a coefficient of any missing terms. And that's what we did. We didn't have an x, so we put 0 there, 0x. Okay, and then to avoid errors, use 0. Okay, so let's try another problem. And here we have 5x cubed minus 6x squared minus 28x minus 2 over x plus 2. Okay, so let's look at how that would work. Okay, so we have, again, we use the additive inverse for our divisor. So here we have x plus 2. So for our divisor, we put a minus 2. And then we need a place. We have 5x cubed minus 6x squared. So we need a place for x cubed, need a place for x squared, need a place for x, and we need a place for our constant. Well, we just used the coefficients. So this will be a 5 for the x cubed. We put minus 6 for the x squared space, minus 28 for x, and a minus 2 for our constant. Okay, any questions there? Okay, what's the first thing we're going to do? You should have said we're going to drop down that first term. So the 5 comes down, and now we're going to multiply our divisor times that bottom row, bottom number. So negative 2 times 5 is a negative 10. That's going to go up in the second row. Okay, now here you have a negative 6 and a negative 10. So the signs are the same. They're both negative. So you're going to add negatives, and you get negative 16. Okay, so now we're going to multiply negative 2 times a negative 16. Negative times negative is a positive. 2 times 16 is 32. So you've got a negative and a positive, but you have to be careful here because you're subtracting 32 minus 28. So you have to borrow the 12, and you get 4. And so you're going to end up with a positive 4 here. Okay, what do we do now? Multiply the divisor times the bottom row again. Negative 2 times 4 is a negative 8. Well, we got a negative 2 and a negative 8. We're going to add or subtract here. You should have said we add negatives. So we get negative 10. So this is our quotient. Ten is our remainder. So you take the 5 and you go 1 less. Since we started with an x cubed, our quotient is going to be 5x squared. It's going to be 1 less because when you're dividing, you're taking 1 away. Minus 16, and you just keep going 1 lower for the x's. Minus 16x plus 4. And now because this is a minus 10, it'll be minus 10 over your divisor is x plus 2. And that's your answer. Okay, any questions with that? Check the answers. If the remainder is 0, then you just leave this off. You don't put 0 over whatever the divisor is. Now, on some of these, okay, so that goes in the next one. All right. Okay. Any questions with that? All right, let's take a look at our our PowerPoint notes again. Okay. So we'll go back to our PowerPoint. And here's the explanation of what we just did. Talked about dropping it down and multiplying. This is using the long division. Okay. Now they have plus a negative 10, but it's basically the same thing. Okay. Special case division. When you're given on some problems, if you're given k as your divisor, if you're given just a single number as your divisor, then what you're doing here is you're taking the divisor and you're multiplying it into the quotient. So in other words, for a problem like this last one, basically what you're doing here is you're taking that divisor and you're multiplying it into the quotient. So this would be x plus 2 times 5x squared minus 16x plus 4 minus 10. So all you did is you just moved the divisor over. Well, when do we do that? We're going to do that with these next type of problems. When you have a problem such as, if we run out of time, just use the same link to come back on. All right, so let's look at the next problem where we have let f of x equal to a negative x to the fourth plus 3x squared minus 4x minus 5, and use f of a negative 3. And we want to use the remainder theorem. So basically, use the remainder theorem to find f of negative 3. So in other words, whatever this is going to be, this negative 3 is our divisor. So when we are already given a divisor like this and it's not as a polynomial, we don't use the additive inverse. We just write it as negative 3. And then we just go ahead and we need a place for x to the fourth, place for x to the third, place for x squared, place for x, and place for our constant. So this first one has a negative in it. That's a negative 1. The next place, well, there's no x to the third, so we put a 0 there. Next is 3x squared, so we put a 3 there because 3 is a coefficient. Next we put a negative 4 because negative 4 is our coefficient for x, and a negative 5. Okay, so now whatever we get for the last term, that's our remainder. So we drop the negative 1 down, and we multiply. Negative 3 times negative 1 is 3. Well, 0 plus 3, that's just 3. And we're going to multiply the divisor, negative 3 times the bottom number 3. We get negative 9. Put it in the second row. So we have a positive 3 and a negative 9. The signs are opposite, so we subtract. We get negative 6. Now we're going to multiply negative 3 times negative 6. Negative times negative is a positive. 6 times 3 is 18. We got a negative 4 and a positive 18. We get a positive 14. We multiply negative 3 times 14. Well, 3 times 4 is 12, right? Carry the 1. 3 times 1 is 3, and 1 more is 4, so that's 42. But it's a negative 3 times 14, so it's a negative 42. And so you got a negative 5 and a negative 42. They're both negative, so we add negatives. We get negative 47. So we can say that f of a negative 3 is a negative 47. That's our remainder. And that's known as the remainder theorem. Let me see if there's anything else to that. Okay, so if we wanted to write the quotient to that, this would be our quotient here. This is our remainder. So since our divisor is negative 3, this would be x minus a negative 3, which would be x plus 3. You have to use the additive inverse when you put it in. So that becomes a plus 3 additive inverse. And then you're going to put negative x. Since we divided, we took away one of the x's, so instead of starting with x to the 4th, we start with x to the 3rd. Plus, the next one is 3, go 1 down, x squared. Minus 6, go 1 down from that, x plus 14. And then minus your remainder, 47. And so this is, if you're given the divisor as a single number, your answer is going to be a different format where you're going to take the divisor and move it out front. Okay, so that's that answer. Any questions with that? All right, so let's go to our PowerPoint notes again. Okay, 0 of a polynomial function is, so what this is saying is if we have 0 as a remainder in our synthetic division, then the divisor is a 0. Well, what is a 0? A 0 is a x-intercept, basically. So we want, if we ever get 0 in a remainder, then you know that's a 0 or a root to our solution.